In this tutorial, we'll create a procedural camera sensor texture in Blender, a pattern that looks like a digital matrix, LED display, or even a solar panel. Let's start with the plane. A full-frame camera sensor measures 36 by 24 millimeters. Apply the scale and assign a new material. We'll begin with the base color. Add a texture coordinate node. First, we'll scale the texture. Since the height is 24 millimeters, we'll normalize it back to 1. There are several ways to create the texture, but we'll focus on building the main structure using the sine node. Therefore, we will also multiply the coordinates by the number pi. Add the sine node, and then follow it with a ceiling node. Since the sine values go from -1 to 1, the ceiling node will turn that into a striped 0.1 pattern across both x and y axes. Separate the vector. Now let's turn this into a Bayer filter. Then use a math node in greater than mode. Duplicate it twice. Switch one to compare and the other to less than mode. Combine them into color channels. Add a hue saturation value node to reduce brightness and connect it to the base color. Set the roughness to 300ths. Next, we'll create a bump map to visually separate the sensor cells. Take the same sine texture, but this time pass it through an absolute node. Separate the vector again. Then take the minimum of the two coordinates. This gives us a grid structure. Use a map range node to isolate only values close to 0. Connect it to bump and then to normal. Optionally, you can round the corners for a smoother look. Set distance to 2000ths and filter width to 0.35. The main part is ready. Now let's add some details, for example a thin film layer. Add a noise texture. You can use the vector add node to shift the noise. Adjust the noise scale to your liking. Optionally, you can offset it a bit. Use a map range node. Normalized noise usually outputs values around 0.25 to 0.75, while the thin film thickness should be around 165-300 nanometers. Connect it to thickness and set IR to 2.5. The thin film effect is done. We can also tilt each sensor cell slightly in different directions. For that, we'll use the same scale, but this time without multiplying by p. Add a snap node. This will divide the UVs into cell regions. Now use white noise to get random colors per cell. Currently, they range from 0 to 1, so we'll center them around 0 by subtracting 0.5 from all axes. That's too much tilt though, so we'll mix it with the default normal to reduce the effect. To do this, add a geometry normal node. Plug the normal to first input and noise into the second input, set a small factor, and connect the result to the bumped normal. The shader for cycles is complete. However, thin films don't work in Eevee. To achieve a similar look there, here are the settings I found most effective. Don't forget to subscribe to the channel. There's much more procedural magic coming soon.